Okay, 5A.6, reflections with points. Now for this section, it will be beneficial to have a formula for the vertical and the horizontal lines that we have, right? We wrote formulas down for y equals x and y equals negative x, but I did not give you a formula for x equals a or y equals a, or like the number or the line x equals 5, right? That vertical line. So it would be a good idea to go ahead and write those two formulas down that I have, and I'll show you how to use them in a second. All right, number one. Just like before, we only care about one point. I'm going to use the point h, and h prime. So we start off with h, which is at 2, 4, and then we go to h prime, which is at 2, negative 2. If we thought about this on a graph, we'd have 2, 4 would be right there, and then 2, negative 2 would be down here. So we flipped over a horizontal line. That's a y equals something. We'll say y equals a. So we're going to end up using the y equals a formula here. So let me go ahead and copy that down here. Okay. I'm just going to use the y part of it because the x part doesn't change. So my y here is 4, and then I end up getting negative 2. So I'm going to plug in, I'm going to have negative 4 minus 2a equals negative 2. And what we're doing there is we're saying, what is a? What is the line that we're flipping over, or the reflecting over? So I'm going to distribute that negative on the left, so I'll have negative 4 plus 2a is negative 2. And then I can solve and I'd add 4, so adding 4. So 2a is 2, and a is 1. So I reflected across y equals 1. So reflect over y equals 1. And that's the line that we reflected, right? In my little graph here, this is the line y equals 1. Number 2, again, we don't need all these points. I'm just going to pick one. I'll pick my x's. So I start off with x at negative 4, 1, and I end up at x of x prime, negative 4, negative 1. So we can see, just like in last time, it is like last time, wasn't it? Yes. Just like in last time, it's the y value that changed, right? So we're going to be using that same formula. We know that there's some kind of y equals a that we flipped over, that we reflected over. So I'm going to use that formula. I'll say, well, y is 1, and then I have the formula negative, what is it? Negative y minus 2a. So this is going to be the same thing as, I'll plug in my 1, and then I'm going to set it equal to negative 1. So I'll have negative 1 minus 2a is negative 1. So I'll have negative 1 plus 2a is negative 1. I add my 1 over to the other side, and I get 2a is 0, so a is 0. Now whenever a is 0, it means that we're on the axis here. So that's the x-axis. So really we're reflecting over x-axis. You could also say reflecting over y equals 0, right? Because the y equals 0 is the x-axis. You could say either of those, and they would be correct. Number 3, let's look at B. We have B and B. If we look here, our second term, our y, stays the same, right? We have 2 and 2. The x goes from -2 to 0. So my x is going to initially be -2, and then I'm going to need to write my formula down, right? And my 0 came from right there, my new point. And this is telling me that there's some line x equals a that we're flipping over, and I need to plug in and be able to solve to figure out what it is. So I'll plug in -2 minus 2a is 0. I'll distribute my negatives and I get, well, 2 plus 2a is 0. So 2a is -2 and a is -1. So I'm reflecting over x equals -1. All right, number 4. Again, let's just find a point. We'll use f and f prime. I think I've said it before, or I know I've said it before, but it doesn't matter what point you grab. They will give you all the same answer, or they should give you all the same answer. If they don't, then you probably made an error somewhere. All right, this one, neither of them stayed the same. So let's write that here. We have f is at 4, 1. F prime is at 1, 4. All right, so neither of them stayed the same. The x's are both different. The y's are both different. So now we need to look at our formula for y equals x and y equals -x. We need to look at those formulas. Well, if we look, it looks like they just swapped spots, right? The swapped spots one is y equals x. So we're going to say reflect over y equals x. Just like that. All right, moving on. Number 5, find the coordinates of the vertices of each figure after the given transformation. All right, reflection over the y-axis. Now, I don't know if I've shown you this before, but so y-axis is the vertical one, right? That's one where the x changes. The x just goes from negative to positive or positive to negative. So you could write down that this is x, y to -x, y, right? So you could use that formula if you want. I think we're going to do that here. Just to show you what I mean by that, if we have something at like -3 over here, -3, 1, we'll say, whenever we flip it, it'll be at 3, 1. So we go from -3 to +3. So q prime here will be 4, -1. R prime will be 3, 2. S prime will stay at 0, 0, because it's actually on the axis. And T prime will be at 2, -3. Something to remember, something that can be kind of confusing, is that the y-axis, the x changes. Number 6, reflection across x equals -2. So I want my formula that I had for x equals a number. So that's going to be -x minus 2a, and then y stays the same. So a is -2. So I'm going to have to plug in for all of these. So here, let me fix my formula just a little bit. It'll be at -x minus 2 times 2. 2 times -2, excuse me. And we can make that formula just a little bit prettier by multiplying those together. So we'll have -x plus 4, then y. And then to make it just easier to plug in, I'm going to change it to -x plus, -x minus 4, and then y, right? I distributed my negative, right? All I'm doing here in the beginning is I take my original formula And I'm trying to initially make my formula nicer so that whenever I have to plug in each of my 4 points, I don't have to do as much work, right? So instead of doing the work 4 different times, I do the work 1 time. So P prime will be at negative 4, minus 4, and then negative 5, right? So I took my negative 4 and I plugged it in right there. I took my y and I plugged it in right there. So plugging in, I'll have, well, P prime is going to be, well, negative 4 is going to be 4, minus 4 will be 0. For Q prime, I'm going to have negative 5, minus 4, and then negative 1. So Q prime will be, well, it's going to be 5 minus 4 will be 1, negative 1. R prime will be at negative 1, minus 4, and then 1. So R prime will be at 1 minus 4 will be negative 3. S prime, to finish it off, will be negative 1, minus 4, and then negative 2. So S prime will be, what is that? 1 minus 4 will be negative 3, and then negative 2. So that is my answer. Now, I know I kind of went through that a little bit fast. Each of these here, you are welcome to type into a calculator. If you don't want to do those in your head, you can type that in a calculator. All right, that's number 6. Number 7, we're reflecting over y equals negative x. So remember, our formula here is x, y goes to negative y, negative x, right? You should have written that down, I think, in the last lesson. So t prime will be negative 2, negative 4. So that will give me t prime is going to be at 2, 4. S prime will be at negative 1, negative 2. So S prime will be at 1, 2. R prime will be at negative 3, negative 1. So R prime is 3, 1. It won't always be that all of these have the double negatives like that. It just happened to be that this problem was like that. All right, lastly, number 8. We're reflecting over x equals negative 1. Is that kind of like what we did last time? Yep. All right, so my initial formula that we wrote down at the very beginning is negative, here, let me change to blue. Negative x minus 2a, and then y. Here, a is negative 1. So before I start, and this is what I did in the last one too, I'm going to try to make the formula, right, because this is my formula, I'm going to try to make it easier to plug in. So I'll plug in my negative 1 right now. So negative x minus 2 times negative 1. So this is going to be negative x plus, negative x plus 1, plus 2, good grief. Just like that. All I changed was right here. I know I fumbled with that. Now I'll distribute my negatives, so I'm going to have negative x minus 2, y. And that's the formula that I'm going to be plugging into. So S prime will be negative 5 minus 2, negative 3. So this will be 5 minus 2, which will be 3, negative 3. T prime is at negative 5 minus 2, negative 2. So similarly, T prime will be at 3, negative 2. U prime will be negative negative 3 minus 2, and then 0. So U prime will be at, what is that, 3 minus 2, which will be 1, like that. And lastly, V prime, negative negative 3 minus 2, and negative 2, which will give me 3 minus 2 is 1, and then negative 2. So there we are. I recognize that number 8 and number 6 can be kind of confusing. And if you end up getting confused, you can always go and graph them. If you ever want to just graph them and do it that way, you're welcome to do that. You don't have to do it by without a graph like I'm doing. If you have any questions, go ahead and email me, and I hope this works out well.